Hello, I'm Jenny Lynch, and this is the Creative Science for Kids podcast.
Hi, I'm Matilda, and today's show is all about nanoscience and nanotechnology.
Let's go nano, with fascinating fast facts about nanoscience, a deep dive into nanoscale structures in living things, a question about nanotechnology, some history of quantum dots, and a nano activity for you to try yourself at home. Listen up, because here come 5 fun and fascinating fast facts about nanoscience.
Facts number 1. Nanoscience is the big field of science about really small things.
Think about something small like an ant. Now imagine shrinking down to 1,000,000 times smaller than an ant. At this tiny size, you enter the bizarre world of nanoscale science.
Facts number 2. At the nanoscale, size is measured in a tiny unit of measurement called a nanometer.
A nanometer is a billionth of a meter. To get an idea of how small that is, let's think about some more familiar units of measurement. A centimetre is 1/100th of a metre, and it's about the width of the nail on your thumb. A millimetre is 1,000th of a metre, and it's about the width of a needle or a pin. For things that are too small for us to see, we have the micrometre, which is 1,000,000th of a metre, and the nanometre, which is 1,000,000,000th of a metre.
Facts number 3. The term nano can be used to describe anything that is between 1 nanometer and 100 nanometers in size.
The way atoms and molecules behave at the nanoscale can change how things look at the larger scale that we can see with the naked eye. We call this large scale the macro scale. For example, at the macro scale, we can see that drops of water tend to stick to each other, and this property is because of nanoscale forces of attraction between water molecules.
Facts number 4. A nanostructure is the shape and arrangement of a material at the teensy-weensy nanoscale. And there are lots of nanostructures in nature.
Nanoscale structures have been found in lots of different plants and animals. One very important nanostructure in nature is the genetic material called DNA. DNA is short for deoxyribonucleic acid, and it's a nanoscale molecule with the width of about 2 nanometers. DNA is in the cells of living things, and differences in DNA lead to the wide range of differences between living things.
Facts number 5. Nanotechnology is the development of useful technology using nanoscience.
Changing the arrangement of atoms and molecules at the nanoscale has allowed scientists and engineers to invent new technologies and materials. There are already a lot of nanomaterials being used today in electronic devices, clothing, and cosmetics.
Let's take a deep dive into nanoscale structures in living things. Scientists have taken a very close look at plants and animals to find tiny structures.
A light microscope can be used to see objects that are too small for the human eye to see, but there's a limit to the tiny size of the structures that can be seen with a light microscope. In the 1930s, a new type of microscope, the electron microscope, was invented, which allowed people to see much smaller structures. A scanning electron microscope can make very detailed images of surfaces. It allows us to see nanoscale structures in animals, like the scales in the wings of the blue morpho butterfly. The bright blue colour of this butterfly is due to nanostructures called photonic crystals. These repeating structures reflect light in a way that creates a bright blue colour from white light. But when viewed from a different angle, the bright blue wings change colour and appear to be dull brown. Geckos are small lizards that can perform incredibly acrobatic feats, all thanks to their super sticky feet. Gecko feet can stick to almost any surface, allowing them to climb up rocks and plants and even scurry across ceilings to hunt for food or escape danger. The bottom of a gecko's foot has lots of tiny hair-like structures that are about 200 nanometers in size, and there's a lot of direct contact between the very large surface area of these tiny hairs and any surface a gecko is walking on. At the nanoscale, more surface area means a huge increase in the forces that make the molecules in the hairs stick to the molecules on the surface.
An example of nanostructures in plants is the lotus plant, which has water-repellent leaves.
By looking at nanostructures in nature, people have been inspired to invent new materials like self-cleaning clothes. The surface of the lotus leaf has tiny bumps which cause raindrops to quickly roll off the surface, and the rainwater washes away dirt to keep the leaves clean.
Now it's time for a question. What are some examples of nanotechnology?
We've already mentioned self-cleaning clothes. These are made from cloth that has nanoparticles on the surface to repel water. Other nanotech clothing has tiny pieces of silver in the fabric to kill bacteria so the clothes don't get too smelly after being worn. The DNA in living things has a code that's used to make molecules called proteins. Proteins are vital for chemical reactions that allow living things to grow and repair themselves. To decode the DNA, there are nanoscale molecules that work like tiny machines that move along the long DNA molecule to read the code. These molecules have inspired designs for human-made nanomachines that could be used to make tiny robots called nanobots. In the future, nanobots might be useful for delivering medicine to the correct part of the body or for working out what's making a person sick. Nanotechnology is being used to improve energy efficiency and to create new types of solar panels to generate electricity from the sun's energy. Some types of sunscreen use nanoparticles of chemicals like titanium dioxide and zinc oxide to reflect the sun's ultraviolet radiation and protect the skin from becoming sunburnt. Minute tubes called nanotubes are made from the element carbon, and they're being used in sports equipment like tennis rackets and bicycle wheels to make them very strong but not too heavy. Modern electronic devices rely on nanotechnology to make them small in size, fast, and energy efficient. And a lot of computer screens and displays like LED screens have nanotechnology built into them. New nanotechnologies are still being developed, and as with any new technology, it does come with some risks. How will new nanomaterials affect the human body and the environment? We know that living things rely on nanostructures like DNA to stay alive, so researchers need to be very careful to make sure any new inventions will not cause harm to the nanoscale structures in living things.
Nanoparticles of gold look very different to the shiny gold you might see in a gold ring or necklace.
Instead of having a shiny gold colour, nanoparticles of gold can look red in colour because of the way the tiny particles scatter light. Our everyday experiences of how the world works at the macro scale can't be used to explain what happens at the nanoscale, but a branch of science called quantum physics is used to explain the weird things that happen in this teensy tiny nano world. The 2023 Nobel Prize in Chemistry was awarded to 3 scientists for their work on a type of nanoparticle called quantum dots. These tiny particles are used in some electronic displays and have been used in medicine to help surgeons to treat cancer patients. Quantum physics predicted that nanoparticles might have some interesting properties, and in the 1980s a scientist called Alexei Ekimov showed that the colour of glass could change depending on the size of nanoparticles in the glass. And a few years later, another scientist, Louis Bruce, proved a similar effect in particles floating in liquid. In 1993, a third scientist called Mungi Bawendi found a new way of making very high-quality quantum dots that could be used in nanotechnology. This work led to these 3 scientists sharing in a Nobel Prize, which is the most prestigious prize in the world. There's still a lot left to discover about the science of quantum dots and how they might be used in nanotechnology, from flexible electronic devices to tiny solar panels or in medicine to diagnose and treat diseases. We can see nanoscale effects all around us if we look closely.
You can try this out yourself using a thin film made from bubble mix. Make sure you tell an adult what you are doing first, and check you have their permission. You'll need some bubble mix, a small dish, and a round bubble wand. It's best to do this activity outside on a sunny day.
If you don't have any bubble mix, try mixing 3 tablespoons of dishwashing liquid with 7 tablespoons of water, and you can make a round bubble wand from a pipe cleaner or a piece of wire.
Cover the bottom of the small dish with bubble mix and dip the bubble wand in the bubble mix. Blow some bubbles and look at the colours in the bubble film.
The rainbow of colours seen in bubbles is the result of thin film interference. Sunlight is made up of all the colours of the rainbow, and the different colours are reflected from bubbles in different ways. With the sun behind you, dip the bubble wand into the bubble mix again. lift the bubble wand out of the bubble mix and hold the bubble wand vertically. Keeping the wand still, look at the bubble film stretched across the round bubble wand and notice the colours that appear in the film. If you're very careful, you will see horizontal lines of colour in the bubble film. The thickness of a bubble film can be measured in tens or hundreds of nanometers, so bubble film has some nanoscale properties. The thickness of a soap film is close to the wavelength of visible light, which is between 400 and 700 nanometers. When sunlight reflects off the front and the back of the bubble film, the light waves interact to become brighter or darker. The colours change depending on the wavelength of the light and the thickness of the film. The soap film is thinner at the top and thicker at the bottom, and this causes the lines of different colours. The tiny amount of time we had together has been ticking away, and now it's time for us to go. Thanks for listening, and remember to stay curious.
The Creative Science for Kids podcast was recorded on the traditional lands of the Bidjigal people. For more information about Creative Science Australia, visit creativescience.com.au.